Good afternoon. This is Craig Double. I'm in the Thomas Edison State University Physics class or course with lab, section Oscar Lima 010, the January 2018 semester. And I'm going to show you my Lab 6 setup. And Lab 6 exercise just goes over the calculating of speed of sound, the speed of sound. In this lab, you're going to need a glass that's good enough to hold this tube so it's not hitting the sides or anything. This is my glass of water here, and it's just regular tap water. I filled this, and I filled an extra container with water in case water evaporated to keep my 17 centimeters and let it sit overnight so that the temperatures would equalize. As you can see, this is the tube that came in my lab kit. I took the measure rule for ease because it has you measure from the top of the water to the top of the tube. I went ahead and measured out each centimeter on the tube. And those are my markings here that you can see on the tube. All right. You also need the tuning fork that comes in your lab kit. My tuning fork is a 384 hertz tuning fork. So that's the frequency for my tuning fork. Yours might be different. Also, it comes with a thermometer. That's the thermometer I'm using. And what I got for temperature of my water is 20 degrees Celsius. And that's pretty much what you'll need for this lab kit. As far as calculations and stuff, I wanted to show you this table. That's why I have it on the screen. I set up my table to work for me here. All these measurements over here on the left. So the air temperatures and the water temperature is going to be your readings, and then the frequency, as you can see, is from my tuning fork up here. We'll talk about these down here later in a minute. The length, again, this is going to be from the measured length from the top of the water all the way to the top of the tube when you're applying the frequency. As you apply the frequency, you're going to have to hold it and bring it down and up. And wherever the volume, where you hear an increase in volume where it gets louder, you're going to mark down the measurements of the length from the top of the water to the top of the tube. And that's where that number comes from. The inside diameter, you definitely want to be accurate with your measurements, as precise as you can. It does affect the outcome of your results. The inside diameter of my short tube here, my 5.5 centimeter tube that comes with the lab kit, came out to be about 0.021 meters. And again, you want to measure that in meters or convert it to meters after you measure it in centimeters or millimeters. I also went to Lowe's and got a 1 meter tube. I'll kind of show you that in the next couple of videos here, experimenting with the 1 meter tube. There's not much of a difference. You don't have to go out there and buy it, but I just did it to see if there was. And if you do get the longer tube, because the lab does call out using a tube that's longer to get the full effect. It doesn't make much difference, but it does help. It does get a little bit louder because I had to use a 5-gallon bucket. But if you do get it, make sure you go a little bit longer than 1 meter when you cut the tube. Don't go exactly to 1 meter for the 384 hertz frequency tuning fork. All right, so again, those are the numbers you're going to enter over here, and then these are all calculated. And all these equations, that's what I'm showing you here in each box. So for the wavelength, this is the calculation that they give you in the lab to use. And I just put it up here as a function. I just kind of want to show you the functions that I use for my table. Once you set all this up, it makes this lab a little more fun, and you can experiment with other frequencies like I did down here at the bottom. All right, here, this one I'm just calculating I get the results from multiplying my wavelength times my frequency. And then for this block here, it's in the lab, it tells you the theoretical speed of sound is 331 meters per second. In the actual book, it talks about it being 343. And you can go on the web and find different, more accurate readings for the speed of sound or theoretical speed of sound. I would just use the one from the lab. It comes with the lab, so that'll get you the measurements based on the lab and what you're using in the procedure. And then there's the percent error right there, the equation for that. Okay, so hopefully that helps you out, but this is the key to making this lab, I think, a little more fun, and you get to kind of, you'll find more time to go experiment with other things if you have availability to it. And it's pretty easy to get these frequencies. There's actually an app I'll show you here. You can go to this website. And this is an online website that you can go to use different frequencies. So on here, for example, I've got 1200 hertz plugged in, and you just hit play, and it makes a pretty annoying sound of 1200 hertz. And you can adjust the hertz and experiment with the tube to see what you come up with. And what I found is, as you go up in frequency, as you can see on the table, the length from the top of the tube to the water becomes shorter, and that's where you're going to hear the loudest part, or the loudest sound as you move the tube. So hopefully that kind of shows you the setup and how to get started. In the next video, I'll do some demonstrations with the different frequencies and the tuning fork. Thanks.